Hello, welcome to Marsh Mathematics, and in this video I'll be looking at the derivatives of trig functions for year 2. Okay, so in the red there, this is the information that you need to know, okay, to solve any of these problems. So you need to know the derivative of sine is cos, the derivative of cos is minus sine, and that the derivative of tan is sec squared. Now you are given this one in the formula booklet, but it's very useful to be able to remember it. Okay, also the reciprocals, the definitions, you'll do this in trig functions. 1 over sine is cosec, and 1 over cos is sec, 1 over tan is cot x. Okay, so also remember that when we find the derivative of a trig function, it's got to be in radian. The angle x must be in radians. Okay, and there's a question on this that I'm going to do. So, and that's just something for you to remember, how to convert degrees to radians and radians to degrees. Okay, now let's have a look at the first example. Now, example 1 is something that you might get in an exam, but I very much doubt it. But it's a way of them getting to see if you can use the quotient rule, because to prove that tan x, that sec squared is the derivative of tan x, okay, you can use why it's a good one is because they want you to, it's a way of them finding out if you know the identity that tan x is the same as sine x over cos x. So you can use the quotient rule. Okay, and there it is. Now they do give you the quotient rule, but if you use it enough you'll remember it, okay, and it saves you time in an exam situation. So you let u equal sine x, because u is the top, okay, u and v. So differentiate sine x, get cos x, v is cos x, differentiate cos x and get minus sine. These results you've just got to remember, okay, and if you do practice enough you will remember them. Okay, now all we have to do now is substitute into the quotient rule, okay, and we get this. Now when we multiply this all out, because we're going to minus minus, we're going to get cos squared plus sine squared on the top. Well, we know that cos squared plus sine squared is equal to 1 from the first year, so they've used, that's a way of them, these two together, of testing on the first year material at year 2, you see, and that's why this could come up, you see. So that's 1 over cos squared, and you should know that 1 over cos, okay, is sec from here, and so the derivative of tan is sec squared. So that's a very good one to test you on the quotient rule, a couple of identities on what sec x is. Okay, so that's that one done. Now example 2 is a simple use of you'd never get something as easy as this, by the way, but it's a simple use of the chain rule. Okay, so it's not sine x, it's, we say really it's a function of sine, but it's also a function of x, and so you might hear it's be called a function of a function. Okay, because if you know y equals sine x, then dy by dx is cos x, okay, but it's not sine x, it's 2x, so it's a function of a function, and so this is where we use the chain rule. So we let u equal 2x, du by dx is 2, y equals sine u, so we differentiate sine, get cos, and then we substitute into the chain rule, okay, and we get, there's your cos u and there's your 2, and you get 2 cos, really what we get is 2 cos u. Well, we know u is 2x. Now a very easy way to do this without using the chain rule, okay, it's a very quick way of doing it, and you wouldn't do all of this in an exam. You would just say, well, it's sine, so it must be cos 2x, but then I must differentiate this and multiply it, okay, because really this is all you're doing is this in your head. So it's the chain rule in your head, and sometimes it's the same if you've got something like y equals cos 3x. To find dy by dx you would say, well, derivative of cos is minus sine 3x, but I must multiply it by the derivative, because it's not x, I must multiply it by the derivative of 3x, which is 3, so it's going to be minus 3x. Minus 3, I should say. Minus 3 sine 3x. There you see, like that. Now, when you can do it as quick, you need to be able to do it as quick as that. You will do with practice, okay? So sometimes the chain rule, you can do it using the long way, the chain rule like I've done, but it's so much easier if you can just do it quickly. Now look at this one. Some people will be able to do this quickly. Watch. It's cos squared x, so really it's a function of a function again. Okay, this is example 3. Now these are more difficult ones, these. Okay, now cos squared, you think, well, it's cos x. Okay, so but cos is squared, so again it's a function of a function. It's not just y equals cos x. Okay, it's squared. So whatever that function is, it's a squared function. So it's almost like big X squared. I say, so it's a function within a function, and that's that's a hint that we must use the chain rule. Okay, so we're going to let u equal cos x, because really that's the same as, rather than use big X, really that's big U squared. Okay, where u is cos x, and that's, so we need to use the chain rule, and we let u equals cos x, we differentiate that, and we get minus sine x. But we know that y equals u squared, so we differentiate u squared to get dy by du. Okay, so there's our two values. We substitute it into there. Okay, and then we know that u is cos x, and we end up with this. Okay, now some people might say, well, I could do that in my head. I can do that, because what I can say is, well, alright, now don't try to do this unless you're really confident, but you can say, well, dy by dx, I'm going to differentiate it as if it's just anything squared. So anything squared, if it's just x squared, so I'll multiply by 2, take 1 off the power, right? But it's not x, is it? It's cos x, so I must times it by the derivative of cos x, which is minus sine x, and we've got exactly the same result as that. So that's how quickly you can do it. Now, number 2 is also a tricky one, because it is in degrees, and I've said that when you do derivatives of sine, cos and tan, it must be in radians, otherwise it just doesn't work. Okay, you can't do it in degrees. The reason it must be in radians is because all of these results, sine, cos and tan, the derivatives are from first principles using radians. Okay, that's why it will not work with degrees. So if it's in degrees, you change it to radians. Now that's the converter up there. X degrees is the same as pi over 180 radians. Then you can differentiate it. We're going to do it the quick way, because all you do is you differentiate sine and we get cos, right? But we then differentiate this term here and we just get pi over 180. And so the answer is a pi over 180 cos, but then we change this back to degrees. So that's a really clever question. Okay, you change it to radians, you differentiate it using the chain rule, but with a quick way of using the chain rule, we just go to cos, then we have to differentiate this part of it, which just gives us pi over 180, we times it, then we substitute back in for degrees. Okay, so that's a clever question. Okay, now number 3 on this is these two is just, this is just the product rule, and this is a quotient rule. Now all you got to do is just be systematic about it. It doesn't matter which one you call u and v, but normally just pick the first one, u and v. Okay, if it pick the first one for u. Now you should know that the derivative of e to the x is e to the x. derivative of tan x is sec squared. So then it's just a question of substituting into the product rule. Remember, you've got to know the product rule. You are given the quotient rule, but you must remember the product rule. Substitute in, okay, and I've just factorized it. So it's just a question of knowing the product rule, knowing the derivatives of e to the x and tan x. Now that's a standard question. Okay, then they might get you to use this for something else. They might ask you to find the gradient at a certain point when x equals 1, etc. You substitute in. Right. Now, for this one, this is the quotient rule. Okay, so we do exactly the same. U is always on the top this time. You can't swap them around. U is sine x, derivative of sine x is cos x. V is 1 plus cos x. So to differentiate that, you get minus sine x. By the way, when you put v squared on the bottom, never do anything with v unless you really have. Unless you're told, just leave it as squared. Okay, because that's in its simplest form. Just leave it as it is. It's the top line that we need to work with. Okay, we substitute it in, and when we expand it all out, okay, we get a cos squared sine squared there, okay, which is 1. And so we've got 1 plus cos x and 1 plus cos x on the bottom. So what we can do, we can cancel one of them, because that's really just 1 plus cos x over 1 plus cos x on cos x squared on the bottom, and so one of those cancels, okay, and so we just get 1 over 1 plus cos x. Okay,